This video we are going to solve some questions related to the differentiation we have discussed in the previous video. So here we have question number 6. Find the unit tangent vector to any point to the curve. Determine, and the second part, determine the unit tangent at the point where t is equal to 2. So at first we have to find out the unit tangent at any point that is in form of this t. So a position vector will be t square plus 1 I cap, 4t minus 3 j cap, and 2t square minus 60 k cap. So here for the tangent vector, we all know that the tangent is basically the first derivative. So for the tangent vector, we will take the derivative of the position vector. So here I am taking the derivative. T square plus 1 is 2t, the derivative of 4t minus 3 is 4, and the derivative of 2t square minus 60 is going to be 4t minus 6. So here is my tangent vector, but this is not the unit tangent. So in order to find out the unit tangent, we have to find out its magnitude first. So its magnitude is going to be 2t square plus 4 square plus 4t minus 6 whole square, and for unit tangent we will divide the vector with its magnitude. You do not need to solve it completely because we cannot find out one single number because of the presence of t in it, so you can just left it in this form as well. Next what we have to do, we have to find out the unit tangent at the point where t is equal to 2. Now simply we have to put t is equal to 2 in this unit tangent, and you can see that we can have now we can have a finite value for the magnitude because we can put the value of t over here. So I get 3 as an answer in this case, or 6 basically. 4 square will be 16 plus 4 square will be 16 plus 4, so it is equal to 36, that is 6. And after solving this expression, we get the final answer as 2 by 3 I cap plus 2 by 3 j cap plus 1 by 3 k cap. This is not included in the solution, you can skip it. Next, we have some differentiation formulas. If a, b, and c are differentiable vector functions of a scalar u, and phi of u be a scalar function of u, then there are some rules that the derivative of a plus b will be equal to derivative of a plus derivative of b, the same as hold for scalar functions. Then derivative of a dot b is equal to a dot derivative of b plus derivative of a dot b. That is what we used to do in the product function for scalar function, product rule for scalar functions. Then for derivative of a cross b, a cross derivative of b plus derivative of a cross b. So basically we are taking the derivative one by one and without disturbing the order and operation. Now derivative of phi of a, here phi is not a constant, it is a scalar function, so it will be equal to phi into derivative of a plus derivative of phi into a. Then derivative of a dot b cross c, you can see that we will take the derivative of functions one by one without disturbing the order and operations. That is a dot b cross derivative of c plus a dot derivative of b cross c plus derivative of a dot b cross c. Similarly, it holds for the vector triple function or product a cross b cross c. So we are taking the derivative one by one without disturbing the order and brackets and operations. So now we will apply these rules or formulas on differentiations. So here we have question number 7. A and b are differentiable functions of a scalar u. We have to prove that a dot derivative of a dot b is equal to a dot derivative of b plus derivative of a dot b. The rule that we have discussed, now we are going to prove it. So here you can see that d by du, or the derivative of a dot b, is equal to limit delta u approaches to 0, a plus delta a dot b plus delta b minus a dot b over delta u by definition. Now delta u of by rules of dot product we have discussed earlier in chapter 2, this is going to be a dot b, then a dot delta b plus delta a dot b plus delta a dot delta b, and a dot b will be cancelled out with this a dot b. Now applying delta u approaches to 0 separately, this will be separate out, that is a dot delta b by delta u plus delta a by delta u dot b, and we will apply delta u approaches to 0 over here as well, and this is going to be, this will be the derivative of b, and this will be the derivative of a, and this will be 0 because of this delta b. Or we can prove it with the help of the other method as well. as we know that a dot b is equal to a1 b1 plus a2 b2 plus a3 b3. Now applying the derivative, we will apply the product rule over here, that is a1 as it is derivative of b plus derivative of a1 into b1. So here you can see that we have applied the product rule separately, and this provide us a vector a dot db by du plus da by du dot b. You have to solve it the b part on your own. Next we have question number 8. A vector A is given as 5t square I cap plus tj cap minus t cube k cap, and a vector B is also given, and we have to find out derivative of A dot B. So by rule, derivative of A dot B is going to be A dot derivative of B plus derivative of A dot B. So I will find out A as it is, derivative of B as the derivative of sine will be cos, and derivative of cos will be minus sine, so it will be plus sine tj cap, and plus derivative of A into B as it is, and then we will apply the dot product over here and get the final answer in this form. Obviously, if you do not apply the rule over here, you can perform a dot b first and then you can take the derivative. As we take the derivative of scalar functions, that is a dot b is going to be 5t square sine t minus t into cos t, and then we will apply the derivative of this on this vector, on this scalar basically. So the derivative is going to be, we will apply the product rule over here, 5t square derivative of sine t plus derivative of 5t square, which is 10t into sine t, plus we will again apply the product rule over here, t as it is derivative of cos t minus derivative of t will be 1 cos t as it is. So here is the final answer. Next we have to find out the derivative of a cross b. So again we can apply the rule, or we can find out a cross b first and then take the derivative. It's totally up to you. In the C part, we have to find out the derivative of a dot a. So we may apply the rule, or we may apply the simple method that find out a dot a first, that is the dot product of a with a, which is given over here, and then we will find out the derivative of the resultant one. Or if we want to apply the rule a dot a, so a dot derivative of a plus derivative of a dot a, and this is going to be 2 times of a dot da by dt. But I think this second method will more easy or convenient as compared to the previous one. Next we have question number 9. If A has a constant magnitude, then show that A and dA by dt are perpendicular, provided that dA by dt is not equal to 0. So we are given with that A has a constant magnitude, and we have to show that the two vectors A and dA by dt are perpendicular to each other. So if we have to show that the two vectors are perpendicular to each other, it means we have to show that their dot product is 0. So as we discussed earlier, that derivative of A dot A will be equal to a dot da by dt plus da by dt dot a. So this is going to be 2 times of a dot da by dt. So this is going to be 0. And why this is going to be 0? Because a dot a is a constant. So if this is a constant, so its derivative must be equal to 0. It implies the answer will be equal to 0. So this shows that a dot da by dt is equal to 0. That is, the vector a and the vector da by dt are perpendicular to each other. So here you can see that we are putting the value of d by dt a dot a. So you can solve it in this way, where that we know that d by dt of a dot a is equal to this expression. Now we will replace this expression with 0 and we will get this equation. So a dot da by dt is equal to 0, that is a and da by dt are perpendicular to each other. You have to solve question number 10. Next we have question number 11. We have to show find out or evaluate the expression for d by dt, v dot dv by dt cross d square v by dt square. So here is a scalar triple product and we have to define its derivative. So we know that we have to apply this rule, as we have discussed, that we will find out or we will apply the derivative on each vector separately without disturbing the order and the product. So this is going to be v dot dv by dt, the derivative of the third function, that is d cube v by dt cube plus, then we will apply the derivative on the second function. So this is going to be v dot d square v by dt square into d square v by dt square plus, and then we will apply the derivative on the first function, that is dv by dt dot dv by dt cross d square v by dt square. Now this is going to be 0 and this is going to be 0. Why these two terms will be 0? Because we know that the cross product of parallel vectors is always 0. So d square v by dt square cross product with d square v by dt square will be 0, and on the other side this term will also be 0. And why this is going to be 0? Because we know that whenever we are having a repetition in the scalar triple product, the answer will be 0, and or we know that whenever we are having two rows or two columns identical in a determinant, the answer is 0. That's why in the scalar triple product, when we are having same vectors appearing two times, it means the answer will be 0. So the two terms will be 0 and this will be your final answer in this case. Next we have question number 13. Prove that a cross d square v by dt square minus d square a by dt square cross b is equal to the derivative of a cross db by dt minus da by dt cross b. So we will apply the derivative over here. So as we know that the derivative of a minus b will be equal to derivative of a minus derivative of b, that is we will apply the derivative on separate functions or the separate products. So this is going to be the derivative of a cross db by dt minus derivative of the second term over here. And now we will apply the product rule over here, that is a as it is derivative of db by dt plus derivative of a cross derivative of b minus we will apply the product rule on this, that is da by dt derivative of the second term, that is db by dt plus d square a by dt square, because we will apply the derivative on the first term cross b as it is. Now what we are going to have, a cross d square b by dt square and minus d square a by dt square, because these two terms are going to be cancelled out. These two terms will be cancelled out, and here we have the final answer. Question number 14 is your homework. You have to solve question number 14.